So this is the Unit 2 retake review for AP Chemistry. And as you guys join, you guys can start putting your questions into the Q&A part of it on the right-hand side. I believe it's on the right-hand side for you guys, I'm pretty sure. So I see Aria. Aria, if you want to, I think you joined instead of viewing it. If you want to go to view it, maybe I sent you the wrong link, but you need to go to the link to view. Anyways, and start posting questions.
Okay.
All right, Aria.
Bye.
Hey. Bye. All right. So nobody has posted any questions yet, which is fine. There are a couple things that I wanted to do. While I'm waiting for a question, I thought that I would show you something from ScienceGeek.net. And so I'm going to share that. Okay. So if you go to the ScienceGeek.net, AP Chemistry, you click on Review, and you get these review activities. And I think that a lot of people we're doing fine with, but it would be helpful to do more combustion analysis. You could also do, what else? Balancing. Anyways, this is a whole stoichiometry thing. So I clicked on combustion analysis, and I got this page, and I said click on new problem, and I got this problem right here. Okay, so now the point is you guys probably can't see that problem. Let's see if I can share that. It's very small, very, very small. No, it's a pop-up window, but it's not big enough to show you guys. So what I'm gonna do is I'm gonna share the bamboo. There we go. And I'm gonna write the problem out for you guys. Okay, so this is a practice combustion. And just out of curiosity, let me look at that. Okay, so it's similar in that you know, we're dealing with carbon, hydrogen, and oxygen in a lot of our problems, and this one's carbon, hydrogen, and fluorine. So it gives us 1.92 grams of a compound, which is C, H, and F. Okay, and out of that we get 1.05 grams of CO2, and out of that we also get wait, I did that wrong. Apologize. 1.05 grams of H2O and 2.56 grams of CO2. Sorry about that. And so you're supposed to figure out the empirical formula. And so from this part, I think that you guys are getting pretty good at it. You know that you can take the 2.56 grams and you can multiply it times the, you want to know, since it's carbon, you want to know the percent of carbon in carbon dioxide, which is, you guys may have memorized that percentage already, but we're just going to do 12.01 divided by 44.01 grams here, okay? And that's gonna give us that 27.29. So I'm gonna plug that in and into my calculator. So 2.56 times 12.01 divided by 44.01, and I get 0.6986 grams of carbon. Okay, so that's how much carbon that was in the CO2. This is the CO2. Okay, so That's good to know. That's how much carbon was in the original sample in the 1.92 grams. Then for the water, I should label these better. We had 1.05 grams times 2.02 grams. This is the H2 in the 18.02 grams of H2O. And I'm going to plug that in. 1.05 times 2.02 divided by 18.02. And I end up with 0.1177 grams of hydrogen, okay? So we have our carbon and hydrogen. So we take our 1.92 grams and we subtract out the 0.698 grams of carbon minus the 0.1177 grams of hydrogen. This will equal our grams of fluorine. So 1.92 minus 0.6986 minus 0.1177, and the amount of fluorine is equal to 1.1037 grams of fluorine. Okay, at this point we need to know how many moles we have of each one. So we would do the 0.6986 grams of carbon divided by 12.01 grams of carbon. Grams per, sorry, I should give the full unit so it's a little bit more obvious. Grams per mole of carbon. And that's equal to 0.6986 divided by 12.01. And I end up with 0.058168 moles of carbon. I went overboard, but it'll be fine. And then let's say I did it for water, and I did 0.1177 grams of hydrogen divided by 1.01 grams per mole of hydrogen. 0.1177 divided by 1.01, and I get 0.1165 moles of carbon. And just looking at that, I think that, yeah, I think that's going to be 2 moles of moles of hydrogen to 1 mole of carbon. We'll do the math to confirm, but I'm pretty sure that's the case. And then last but not least, we have the fluorine, which is 1.1037 grams of fluorine divided by, and fluorine, I think it's 19.00 grams per mole of fluorine, and that equals 1.1037 divided by 19. Oh, that's interesting, 0.05808. So I would say that what I'm going to do, I'm going to change colors of my ink for a second, do the greens. I would say that these two are basically the same. 0.058, I mean, the differences between those the other two numbers beyond the 58 is pretty minimal. I would say that we'll give purple to this one. It's 2-to-1. What you would need to do, I'm going to do it on the next page, but just, you can eyeball these things and figure them out. So my guess, before I actually do the math, is going to be, is going to be a CH2F. That's my guess. That's my guess. We'll do the calculation for it though. Okay, so we had, so our smallest one was, I guess I have to go back because I don't remember. So our smallest one was the fluorine. So fluorine on bottom, so 0.05808. Let's say we put the hydrogen on top, 0.05808. 0.1653. So I plug that in my calculator, and voila. Remember that we're basically looking for pretty much whole numbers. Mine says 2.00637, and you can just say, humbug for all this stuff. And basically your answer is going to be 2. So it's 2 hydrogens to 1 fluorine. And then if we do fluorine over, fluorine was the smallest. My mistake. We do carbon over fluorine. If you remember, that's 0.05808. And carbon was, of course, I can't remember this one, 0.058168. 0.058168. 0.058168 divided by 0.05808. And it basically comes out to 1.001515, blah, blah, blah. You know how I feel about that stuff. So 1 chlorine to 1 fluorine. 1 carbon to 1 fluorine. So our answer, yay, C, F2, H. Oh no, haha, I'm just kidding. Big joke. Let's try that again. C, H2F, sorry. Okay, and when I wish you guys could see the little pop-up box, but I click on the CH2F, and then I go to hit submit, and it should, oh no, I got it correct. We got it correct. We did good work. We're smart. Okay, let's see if you guys have any good questions now. Multiple choice number 2. I'm assuming that's from the real test, or the unit test, not the practice test. So I'm going to go ahead and do that. Screen share. Wait, where are you? Okay. Screen share, stoichiometry, unit test. All right, there it is. A 27-gram sample of an unknown hydrocarbon was burned in excess oxygen to form 88 grams of carbon dioxide and 27 grams of water. What is the possible molecular formula of the hydrocarbon? All right, no calculator. This is multiple choice. So I just set my calculator aside, and I'm going to open up my Bamboo tablet, and we'll go ahead and get to work on this one. Okay. So this is, let's do this back in the blue. Test, multiple choice, number 2. Oh, I need to click that I'm doing it right now on the. Okay, multiple choice, number 2. Now, we're doing this all on paper. 27-gram sample. 27-gram sample of a hydrocarbon, which means it is just carbon and just hydrogen. There is not a third substance. So it was burned in excess oxygen to form 88 grams of carbon dioxide. So from this, we are getting 88 grams of CO2. And from this, we're getting 27 grams of H2O. What is a possible molecular formula for the hydrocarbon? So you would take the 88 grams of carbon dioxide, and multiply it times, oh, you don't even have to multiply it, I'm sorry. At this point, since you have the mass there, you want to know what, how many moles it is. You just go straight to moles. So we can say 12, oh my goodness. Let me rephrase that. How many moles of, having some issues determining the direction I should go in. Let's try this again. Sorry, I got my pen back. All right. If it's 44 grams of carbon dioxide, we want to know how many moles of carbon dioxide is that, okay? And we could say that 44.01 grams per mole of CO2 gives us, so 88 divided by 44 is 2, so 2 moles of carbon, or of CO2, 2 moles of CO2. And for every, this is a really shortcut way of doing this, by the way. For every 1 mole, if we want to make a little bridge, for every 1 mole of CO2, that gives us 1 mole of carbon. So we have, when all is said and done, we have 2 moles of carbon, okay? So that's what we have, 2 moles of carbon. For the water, it was 27 grams of H2O. If we divide that by 18.02 grams of H2O, 9 goes into 18 twice, 9 goes into 27 3 times, right? So, and this is grams per mole. So when this is all said and done, we have 3/2 moles of H2O. And for this, for every 1 mole of H2O, we end up with 2 moles of H, right? Because you see here, see the 2? So for every 1 mole of a water molecule, you end up with 2 H's out of that, okay? So when those cancel out, you end up with, I'm sorry, the 2's cancel here, leaving you with 3 moles of hydrogen, okay? So, and if you remember, you want to, well, the ratio of just H to C makes it pretty easy, actually. We'd say, oh, well, the answer must be C2H3. And we look at the answers, and that is not one of our choices. However, C4H6 is a choice. And that would be a molecular formula, right? This would be the empirical formula. And then this would be the molecular formula. Okay? So, yeah, so you can do it that way. And that's how you can solve number 2 of the multiple choice. Hopefully that helped you. Okay, the next one up, Joanne would like to see multiple choice number 10. So, multiple choice 10 sounds good. I will select that on our, so we can all see it. Multiple choice number 10. What mass of hydrogen is displaced when 6 moles of iron reacts with the hydrochloric acid down below? So this one actually, this could be kind of fun. This is just straight stoichiometry across, just we can make a long bridge. So I'm going to go ahead and share my bamboo tablet. All right. So we're going to go to the next page, switch back to blue, multiple choice number 10. So, oops, I covered up my test, I can't see, okay. So, it's displaced when 6 moles of iron react. So we have 6.0 moles of iron. Excess hydrochloric acid, no big deal. We have our equation. I should write that up here just so you guys can see. 2Fe plus 6HCl yields 2FeCl3 plus 3H2. And they want to know how much hydrogen basically is produced, okay? Because we're mass of hydrogen. So they're looking for this right here, looking for the H2. So, since I'm starting with moles, I can go straight to the mole-to-mole ratio. For every 2 moles of Fe, we have 3 moles of H2. And for every 1 mole of H2, we get 2.02 moles, or grams. Well, hello. Lo siento, sorry about that, guys. grams of H2. And so if I do that, then if I say 2, let's see if I can use 2, gives me 1, it goes into 6 3 times. 3 times 3 is 9, 9 times 2 is 18, basically. 18, like 18.18 grams of H2. And if I double check, that is the answer, except that there was no 0.18, it was just 18.0. That's the answer. Not too bad. Again, it's nice when it's actually just a straight bridge. Hopefully that will help. Okay. Our next one, Joanne, is free response 1C. So let's look at free response 1C. Oh, I went too far. Free response 1C. Okay, since the answers are up there, I'm not going to write the whole thing out. The same reaction as above. So this made it difficult. If you guys remember that I said, I didn't want to have to go and grade everybody's paper for math differently. However, I will do that for the retake to make sure that everybody gets the max amount of points. So you have this equation. The sodium sulfate plus barium phosphate yields barium sulfate plus sodium phosphate. And after you do all this, you determine that the sodium sulfate is your limiting reactant, and that your two products are barium sulfate or sodium phosphate. And in this one, in B, you had to go to barium sulfate. In C, you're going to a different product. So you started with your limiting reactant. And because limiting reactant was sodium sulfate, you start with your 454.72 grams of sodium sulfate. You got the mass of the sodium sulfate down here to 1 mole. Then you do the mole to mole ratio based upon the balanced equation. Then you multiply it times the molar mass of sodium phosphate. And that gives you your mass of sodium phosphate. Once you have that, that's your theoretical yield. That 349.86 is your theoretical yield of sodium phosphate. Once you have that, then you can find your percent yield. It said experimentally you made 103.2 grams. Well, then you can just do 103.2 divided by the 349.86 times 100, and that gives you your percentage. So I think what probably messed a lot of people up is by the time they got here, everything was so messed up with the math that it just wasn't even possible for them to get the points. But again, if you get to this point and you're not sure on the retake test, just go ahead and take a best guess shot. And as long as if you start with a number, like I don't care what the number is, I mean, it has to be reasonable. And you do this process correctly and you get a number, and you do the percent yield correctly, even though it's a wrong number, I'll give you could still potentially earn both points here, even if you totally messed up the 2 parts above it. So hopefully that you're able to do that and have the presence of mind to just go ahead and, even if you get flustered, just go ahead and make up some numbers that are reasonable. And if you know how to do the problem, show your work. If you know the process for doing the problem, show the work, and you'll be getting points for that. Okay, now that question is finished, and we're on to free response number 2. Already had a question about free response number 2. So let's go ahead and scroll down, and again, it shows it all, so I'm not going to show my bamboo tablet. Here it's kind of broken up a little bit for you. This is just like I did with the carbon, hydrogen, and fluorine earlier, except for that we have carbon, hydrogen, and oxygen. And most frequently it's carbon, hydrogen, and oxygen, but and you never know, on the test, they might do 4 things: carbon, hydrogen, oxygen, and bromine, like we did on the practice. Anyhow, combustion of a 3.4 gram sample of this compound produces 6.79 grams of carbon dioxide, 2.7843 grams of water vapor. Okay, so we look at that, and we can take that immediately, and we can figure out, see here, the 0.2729% of CO2, that's that 12.01 divided by 44.01. So you could have this memorized and just put it out there, and it's actually acceptable. In this situation, that's acceptable. So the 6.79 times that gives you the grams of carbon. You multiply the water vapor times its percentage for hydrogen, excuse me, and you get the mass of hydrogen in your original sample. You subtract them both from the original mass, the 3.4 grams, and that gives you the mass of oxygen. That's step one. You get a point for that. Then, Then you get a point for turning all of them into moles. Because once you have the mass of each, you need to know the mole ratio. So you take each of them, you divide by the molar mass of the element, and you get the moles. And whichever one is the smallest, in this case, it's oxygen, you're going to divide the others by oxygen. That means oxygen is your 1, right? That's your, when you write the formula, it's going to be your 1. So you can see that, the oxygen goes into hydrogen 4 times, the oxygen goes into carbon 2 times, so it's C2H4O. Then the next part of the problem is saying that the molar mass of the compound is 44.06 grams per mole. What is the molecular formula? The last point is earned by taking that empirical formula and figuring out what the molecular formula would be. Well, as it turns out, the empirical formula's mass is 44.06. So it's the same as the molecular, or it's the same as the molar mass of the molecular formula, so the empirical formula is the molecular formula. Does not happen very often that way. It does happen here. Will not be the case on the test. I think that on the test, all you're doing is actually just finding the empirical formula. Oh no, you do it. You have a molecular formula. It's definitely not the same. So very similar, very similar. I have this broken up a little bit more. There's an opportunity to get more points on this one because I've broken it up a little bit more. I think that you should have another point for getting the empirical formula, then another point for getting molecular formula. Anyways, I just have it more broken up. So there's more points there to earn. I think a lot of people did well on this, and I think they should be rewarded for that on the retake. So, okay. So those were the questions, the combustion. I don't see any other questions in the column right now, which is quite all right. I would say real quick though that there will also be a question about the oxygen atoms. You're going to have a hydrate question. You're going to have to determine, in this particular question, you didn't have to determine the number of waters in the hydrate. I think you did in the multiple choice. Let me go back and look for a second. Yes. Okay, so for number 4, you had to figure out the number of hydrates, or the number of waters in the hydrate. I'm sorry, number 4, you had to figure the number of hydrates. You're going to have to do that in the free response. So the same way we did it here, if it loses 54.3% of its mass, that means that 54.3% is water. So you divide that by the 18.02, and you get the number of moles of waters. And you compare it to the moles of the sodium carbonate you have. So that if you had 54.3% water, or 50, whenever it's a percent, you can just change to 100 grams. So 54.3 grams of water over 18.02 grams is like a 3-to-1. And the sodium carbonate is I can't remember. Anyways, it's like 45 something. And you can figure out the water from, figure out the moles of the sodium carbonate. Once you've done that, I see that Joanna's put in a question. So it's the same one. So why don't I just select that, since that's one I am talking about right now. You have, you take if you did number 4 and number 4 from the multiple choice, and combined it with number 3 in the free response, you would have the free response for this upcoming test, right? You need to be able to calculate the amount of waters in a, why don't I just do it? This is all gonna be a part of number 3. Okay, let's look at number 4 together. Okay, number 4, right here. And So we have that. So now I'm going to go to my bamboo tablet. Okay. So let's pretend for a second that this is on the free response, which means that you can use your calculator. So if you had 54.3 grams of water divided by 18.02 grams per mole of water, it's about 3 moles of H2O. And if you had 45.7 grams of sodium carbonate or sodium bicarbonate, and sodium is basically 23, let's see, 23 times 2 plus 12 plus 48, and I get 106 grams of Na2CO3. And because this is, I'm pretending this is on the free response, I'm gonna go ahead and use my calculator. 45.7 divided by 106, and I come out with 0.4311. Did I do that right? 54.3 divided by 18. Yeah, I did. Well, that's interesting. Okay, well, I think this is underestimating a little bit. I don't think that was good numbers. All right, sorry, I'm a little distracted. So 3 divided by 0.4311. Oh, I see, it is, okay. So you have to divide the larger one by the smaller one. So 3 moles of H2O divided by 0.4311 moles of, oops, I didn't finish, Na2CO3, so the sodium bicarbonate, actually ends up being equal to 6.9589. And when you do this, you need to be pretty close to whole numbers, because you can see by the choices that it's all whole numbers, but it's going to be whole numbers. You're not going to have fractions. So when you look at that, it's that many moles of water to 1 mole of Na2CO3. So we might as well just change this to 7. 7 to 1. Na2CO3.7H2O. So you've done, we're going to pretend like this is the free response and the retake, you've done that part. Then the next part is going to say, okay, now how many atoms, oxygen atoms are there? Which is what this is, right? Let's go back to that question for a moment. Un momento, por favor. Okay, how many oxygen atoms are there in 45.32 grams of this? Okay, and in this situation, there's 10 H2Os. So you have your mass and of this compound, the big long compound. And it's just, think about it as a grams to moles to atoms. It is just a straight conversion, okay? So you convert grams to moles. Once you have the moles of your substance, you can multiply it times the atoms. The only other thing is it's not looking for atoms of the whole thing. It's looking just for the number of atoms of oxygen, okay? So if you have 1 mole of this whole substance, or yeah, you have 13 moles, or if you have 1 molecule of this, 1 molecule of that, you have 13 atoms in that 1 molecule. So all you have to do, if you do 1 extra step, and that is multiply times the number of moles of oxygen in 1 mole of the substance, or number of atoms of oxygen in 1 atom or molecule of this. You get the general idea. So that's the only additional step. But this is the same thing you did in Gen Chem with a grams to moles to atoms. Okay, it's just as if this part down here just didn't exist though. Okay, so it's a little tricky, but you guys can manage it. All right, so that ends number 3. Whew, I made that a lot harder than it needed to be. All right, so Aria is asking about multiple choice number 2. So we cruise up here. Wait, didn't you already ask about multiple choice number 2? Did I do the wrong one? What's going on here? Aria, you tricky boy. I did this at the beginning. I did the multiple choice number 2 already. Go back up there and look at it if you're not sure. Funny guy. Okay, so that one's done. Just go back to the beginning and watch it. Okay. While I give you guys a moment to look up questions, I'm trying to think of anything else. You guys will have to write out a reaction for one of the problems. You guys will have to do a limiting reactant problem with a % yield. And a hydrate. I guess it's all, I mean, it's very similar in setup to the other test, just mostly different numbers. Oh, that's right. Aria sent it. Oops, sorry, that's okay. So, all right. So I don't really have anything else to go over. I mean, I would, if you've gone back and looking at you've gone back and looked at the review sheets or the worksheets for the unit, you have done the practice test again, maybe you've looked at the actual test again, I would encourage you to go to sciencegeek.net and practice some problems. And see what you can come up with. You can always come and see me if you have questions tomorrow, since we've got a little bit more time to go over it. I'm trying to think of other things in the sciencegeek.net because I don't know if he did a hydrate thing. Combustion analysis. I don't see a hydrate thing. That's okay then. You can look up, you can just type in hydrate. Oh, you can go to practice problems from Adrian Dingle, and he might have something. Anyways, I can't think of anything else. So I'm not just gonna hang out here. I'm sure it would bore you guys as well. So I'm gonna get off. But again, if you have questions, email me or come in and see me. You know, I get there early in the morning. So good luck. Oh, could you do a sample hydrate problem like the one on the practice test? On the practice test. Let me pull that one up real quick. Do I still have that one open? So this isn't the actual test, this is the practice test. Let me take a look. So, oh no, this is the actual test right here. No, where's the practice test? I thought I had the practice test open as well. Where is it? Oh, here we go. Okay. All right, could you do a sample hydrate problem like the one on the practice test? So I'm assuming you're looking at free response number 1 right here. You want to see a hydrate problem like that. Washing soda is a hydrosodium carbonate. What is X? Interestingly enough, that 10 was just like in our practice, or not a practice, in the actual test. Okay. I have a few of those to draw from. But to get to them, I'd have to open my school stuff. I can do that, actually. I think I can. Oh, I know where I can go. Bear with me one moment while I find. Okay. Okay, here we go. All right, I'm gonna need to share the bamboo paper. All right, put a new one. All right, so in this problem that I'm going to do, we have a 15.67 gram sample of magnesium carbonate. And it's a hydrate times X H2O. And you drove off the water. The mass was reduced to 7.58. Okay, so you had 7.58 grams of the magnesium carbonate left over at the end. What is the formula? What is this X going to be? Okay, so if you had 15.67 to begin with, minus 7.58, then you also end up with 8.09 grams of water. So we know we're going to divide this one by 18.02 grams per mole of H2O. And that, let's do that really quick. 8.09 divided by 18.02. And we will end up with 0.449 moles of H2O. Okay. And the magnesium carbonate, I have to go to my periodic table and remember to write offhand. 24.31 plus 12.01 plus the 3 O's is 48. And if I did this right, I end up with 84.32. So 84.32 grams per mole of magnesium carbonate. So 7.58 divided by 84.32, and I get 899 moles of magnesium carbonate. Okay, we divide the larger one by the smaller one. 0.0, no, did that wrong. Okay, 0.449 divided by 0.0899, and this is the moles of H2O over the moles of MgCO3. 0.449 divided by 0.0899, and I come out with 4.99443, blah, blah, blah. You know how I feel about that. It's going to be equal to 5. 5 moles of water over 1 mole of magnesium carbonate. So the formula, if we write this all out, MgCO3 times 5 H2O. So that is how you do a hydrate problem. Hopefully that went smoothly enough. You guys made sense to you. Okay, and I just think I saw another question. Yes, I did. Aria wanted to know about multiple choice number 9. So I'm assuming again that this is the unit test you're referring to, Aria. So I'm going to go ahead and share that document. And go to number 9. I'm going to take a quick sip of water. Thank you. All right, so a sample of potassium nitrate is mixed with a small amount of impurity. It was found that the overall sample consisted of 20% potassium by mass. What was the approximate percentage of KNO3 in the sample? All right, so this is a multiple choice where we do not have our calculators. We're not allowed to use our calculators on this. So I'm going to go ahead and switch to my bamboo. And there we go. All right, this is multiple choice number 9. All right, so you have 20% potassium by mass of the whole thing. So that means 20 grams. Let's say it's a 100-gram sample, 20 grams of it is potassium. So if 20 grams of the 100-gram sample, we just always use 100 grams because it's easiest. 20 grams of the 100-gram sample. So what we want to know is how many moles is this? Because that's what we usually do. As soon as we get mass, we divide by the molar mass. And the molar mass is 39.1, right? Yes, 39.10 grams per mole of potassium. Well, basically, that's like 40 because that's a lot of extra work since we don't have our calculators. Okay, so once we do that, then we say, well, that's basically 1/2 mole of potassium. Well, if you have half a mole of potassium, we'll call it 0.5 mole, just for fun. Then we can figure out how many moles of potassium nitrate. 0.5 moles of potassium. And for every 1 mole of potassium, we have 1 mole of potassium nitrate because it's a 1-to-1 ratio, 1K. There's only 1K in KNO3, so it's a 1-to-1 ratio, which means we have 0.5 moles of KNO3. Okay, so if we have 0.5 moles, we can determine the mass. Remember, we said we had a 100-gram sample. Because we were dealing with percentages. Okay. So 0.5 moles of KNO3. Ugh. That is just the ugliest KNO3 I've ever seen. We're going to redo that. Good. All right. For every 1 mole of KNO3, it said we have 101 grams of KNO3, which might as well be basically 50 grams of KNO3. So 50 grams of our sample is KNO3. And our sample is basically 100 grams, which we already established. And that's the total. So 100, or 50 divided by 100 times 100 equals 50%. And as it turns out, 52% is an option. It's B. And that's the closest one. That's the one I'd pick. That's the answer. Answer is B. Woo. Okay. All right, so that answers that question. All right. Okay. No more questions? I'll give you guys a few seconds to think about it. Nothing coming to mind? Okay. Well, if there are no more questions, then we'll go ahead and end here. There were great questions, and I appreciate that. There's things that I would anticipate that you would struggle with hydrates and with combustion. Hopefully you guys are on the right track now. Stoichiometry. I'm hoping this retake goes well. I spent some time today going back through it, reviewing questions, reviewing answers. I made some changes. I think it'll be a good test. So, but please come and see me if you're struggling or if you have questions. All right. Thanks, guys. And I will see you tomorrow. Tomorrow's Blue Day. How about that? Our test is until Thursday morning, though. All right. Bye.